Hey everybody, so here is the chapter 2 guided problems. So I guess we'll just jump into them. The first one here is the accompanying table contains ocean temperature data in a tourist region for the past 125 days. Complete parts A through E below. Then it's going to tell us to click on the data table and it's going to give us all of this data. And then we're supposed to use the 2 to the k is greater than or equal to n rule to construct a frequency distribution. So if you remember, this 2 to the k is greater than or equal to n. That just relates to how we should split up our sample, how many categories or how many I guess how many groups we should separate it out into. So if we want, we can export that to Excel. It'll take a second to open up in Excel. Maybe there it is. And it tells us that it was for the past 125 days. So our n is 125. Okay. So sometimes what I do is I just come in here and I just say, so 2 to the k, right? So we can tell Excel, like if k is 1, 2, 3, 4, 5, 6, whoops, 5, 6, 7, 8, 9, 10. So if k is one of those, then 2 to the k, this will equal 2 to the k, or 2 to the first power here. And then once we have that formula in, we can just bring it down there. So if 2 to the k, where the point at which 2 to the k is greater than or equal to n, if n is 125, would be at 7, right? Because at 6, it's 64, so it's less than n. But at 7, it's 128, which is greater than 125. So that means we're going to divide this data up into 7 groups or 7 categories. So we can look at that right now and say, okay, this one has 1, 2, 3, 4, 5, 6, 7, 8. And this one has 1, 2, 3, 4, 5, 6, 7. So we know this is going to be the one that we use. So now what we have to do is we have to construct a frequency distribution. So we can have Excel do a lot of the work for us simply by, we'll put the highest number in each of our categories. Okay, so I'm going to do 72 and 74, 6. So it's the highest number in each category. 78, 80, 82, and 84. So what we're doing is telling Excel, look for numbers that are, in this case, less than 72, and then less than 74, but greater than 72, etc. And then we have to do this. So we're going to highlight this entire, and so we're going to highlight this entire area here, and we're going to do equals frequency. And so the first thing it wants is our data array. That's all of this information. This is our data array, all 125 data points, comma, our bins array. And our bins are these, it calls them bins. It means the numbers that it's looking to sort this data into. I guess like a bin at the grocery store for apples, right? You sort the different types of apples into different bins. Well, so bins just mean categories. And I'm going to close the parenthesis. And now I have to do this weird thing where I hit Control, Shift, and Enter. And people miss that part. The other thing they often do wrong is they just highlight this top one, then they try to fill the data down. And that will cause a mistake too. So you have to highlight all of them, put in equals frequency, highlight the data array, and then the bin array, and then Control Shift Enter, and it gives us our frequency distribution. So there were 2 that were between 70 and less than 72. There were 20, 72 to 74, 47. And I promise you, this is way easier than trying to just count them all. Just takes a little practice to get used to how to do it. And there's our frequency distribution. All right, second part. Using the results from A, calculate the relative frequencies for each class. Select the correct choice below to fill in the answer boxes. So relative frequency just means take it as a percentage. Okay, so what I'm going to do first is I'm going to total up all the frequencies, and it should add up to 125, right? There's 125 total. And now to find the relative frequency, I'm just going to say this equals the number there are, so this is 2, divided by the total of 125. Now if I leave it like that, and I try to fill, then what's going to happen is Excel is going to think to move both this number and this number down each time. So what I have to do is I have to tell Excel, leave D21 alone. And the way I do this is by putting these little dollar signs around it. So it's going to take, when I fill, it's going to take this number divided by D21 each time. And that will work for us. So there's my relative frequencies. Round to the nearest thousandth, so that's 3 decimal places as needed. Again, it's going to be this one that has 7 categories in it, right? Because it's still the same data as before. And then I'm going to put in these numbers. That's the relative frequency, 0.016, 0.16, or 16% of them are 72 to 74, 0.376, 0.288, 0.12, 0.032, oops, and 0.008. Check our answer. All right, we got it right. Now it's going to ask us to do a cumulative relative frequency. So cumulative just means adding up over time. So what we're going to do to get our cumulative relative frequency is we're going to say this first one just equals the first bin, 0.16. But the second one is going to equal the first bin plus the second bin. And the third one's going to equal the third bin plus the first and second bins. So it adds up over time. We should be able to just fill that down, and at the end it should add up to 1, meaning 100% of all of our values are contained in all of the bins. Okay, so our first bin is 0.016 or 1.6%. Our first and second bins together are 0.176 or 17.6%. Third is 0.552 or 55.2%. Fourth is 0.84 or 84%. So that's interesting. We can say in these first 4 bins, 84% of our data points are contained in those first 4. And we get to the 5th bin, 96%. And then the 6th, 99.2%. And then 100%. All right, so now they want us to construct a histogram. And while it's possible to use Excel to do this, honestly, for these problems, I usually don't. I just sort of like look at the data and you can look at it pretty easy. So you can, so this represents the temperature on the x-axis, and on the y-axis, it's the frequency. So we know that we're gonna go in the first category here, there's gonna be 2, then 20, then 47. So I can kind of look at these and say, okay, all 3 of these have 2 in the first one, but the second one has to be around 20. So this one's already out, right? Because the second one's not even 10. But this one, they could both be around 20. Our third bin has to be about 47. You can see here, our third bin's around 30, and here our third bin is just under 50. So this is the correct answer. So that's what I do. If you want in class or individually, I could show you how to how to make a histogram, but it's often not worth the effort unless it's something you need to do for a real life situation. Anyway, so there we go, and that should be the end. Oh no, we have one more. Let's see. For what percentage of days was the ocean temperature less than 74 degrees? So we can look right here and say, okay, so the cumulative frequency here is or cumulative relative frequency is 0.176, or 17.6% of the data points were 74 and below. So we can just say, and here's an interesting thing. Up here, it wanted us to put them in decimals, but here it shows a percentage, so we have to be careful and recognize that we're going to record that as 17.6%. And there we go. That's the end of the first problem. Let's move on to the second problem. All right, here's our second problem. The accompanying table shows the real gross domestic product for various countries in 2006 and 2016. Construct a display that best describes the data. So we're going to click on this. I'm going to minimize my Excel. Oh, I've got too much going on over here. Maybe I need to maximize that. All right. So here's our data set. And you can see the United States has 14.79 and 16.92. And so our first thing would be to say, well, which of these is a better way to display this data? And the answer is it's got to be these comparative bar charts, right? Because if we were to use a pie graph, that's usually for if we're doing something that's not time series, just because it's hard to see any real change or anything like that. Whereas this shows us the change in each country over time. So it's going to be one of these two, A or B, that's our better comparison. So now we just have to look at this and compare the two. And so we see that the United States was 14.79 in 2006 and 16.92 in 2016. So just under 15 and somewhere between. So that looks pretty close, and that looks pretty close. So those two doesn't count either one of those out for us. Japan 5.75 and 6.05. So we can look at, actually they have them in a weird order here. So there's Japan 5.05 and 6.05. That looks good. Here you can see Japan is way low. It shows it like under, well, yeah, it never gets over 6. So already we can say B is correct. We could compare these other things if we wanted to too. You can see that Germany has a little growth, France has a little growth, and then Italy's went down a little. But that's really all we need to do to work out the problem. That's it. So on to the third question. All right, so here's the third problem. This one's going to have us create a contingency table. Excel uses the term pivot table, but it's the same thing, okay? So I'm going to show you how to use Excel to make a pivot table. So the first thing I'm going to do is open up the data and open it in Excel. There it is. All right, so the Excel data is listed out, just store and rating number. So what we're going to do is we're going to highlight these two categories, and then we're going to go to Insert, Pivot Table. It's going to ask us which data it's pulling from, and since I've already highlighted them, it knows. I could highlight them after the fact and put them here if I want to. And then it wants to know where I want the pivot table placed in a new worksheet. I'm just going to have it put it in this existing worksheet, and then I'm going to tell it, go ahead and put it right here at E19. I hit OK. Now it wants some information from me. And so it's going to want to know what my columns and rows are and my values. So my columns, you can see right here, are store A, B, and C. I can tell that because that's how they want the answer formatted. So I'm going to take store and drag it down to columns. And now I can see my pivot table starting to form here with A, B, and C and a total across there. And my rating then is going to be my rows, the part that goes across there. I'll drag that down to rows. And finally, for values, I also want to use ratings. However, if I leave this as sum of ratings, I'm going to come up with all these weird numbers. It's just going to be adding them all up. When really what I want it to do, I'm going to click on this drop down arrow and click value field settings. And I don't want the sum of each of those ratings. I want the count of each of those ratings, because what I'm trying to figure out is how many for store A, how many ones, how many twos, how many threes, how many 4 ratings did they get, etc. So I'm going to do the count. I hit OK. And now I can see that I have this completed contingency table, or pivot table as it's called. So I can say, look at here and say, okay, store A had 5 1 ratings, 9 2 ratings, 4 3 ratings, and 2 4 ratings, and 20 total ratings from store A. So all I have to do is put that information in. Oops, let me pull that back up. Every time I type on this, it's gonna, there we go. All right, so store A had 5, 9, 4, and 2 for a total of 20 ratings. Store B had 0 1 ratings, 3, 5, 7 for a total of 15 ratings. Store C had 2, 2, 9, and 2 for a total of 15 ratings. And then the totals were 7, 14, 18, 11, and 50 total ratings. And then it's going to ask me to sort of interpret this data a little bit. So what conclusions can be drawn? So I'm just going to read each of these and then compare them to what I see up here. Store B received about 64% of the 4-star ratings. So I can say, okay, there was 11 total 4-star ratings, and 7 out of the 11 belong to store B. So if I take 7 divided by 11, that's about 64%. So that could be right. While surveying 30% of the customers. So store B had 15 out of the 50, which is 30%. Store B seems to have higher customer satisfaction than others. That's true. So I'm going to guess that one, and I was right. If that one wasn't right, I'd have to look at each of these and compare them against the data. Remember, that's what we're really trying to get at with statistics, is we want to be able to create meaningful data that we can then interpret to make decisions. And in real life, if I was the regional manager, I would say, okay, what is store B doing that stores A and C are not? And we would try to steal some of store B's good ideas so that we can improve the customer satisfaction in all of our stores. All right, so now we will move on to question number 4. All right, so the table shows the ages of the top 40 golfers in the 2009 golf tournament. Construct an ordered stem and leaf display. So again, we'll open our data, open it in Excel. It'll take a second. We'll enable editing. All right. All right, so here's all of our data. So remember, a stem and leaves display just sort of breaks it down by putting the tens place, or whichever, in this case, these are all 2-digit numbers. So the tens place and then the ones place over here. So to make this easy, all I'm going to do is I'm going to highlight all of these, and then I'm going to go up to, sorry, I can't see this well. I've got, let's see. I'm going to go to data, and I'm going to go to sort, and I'm going to tell it I want column A from smallest to largest. So now it's pretty easy to see how it breaks down. I've got the twos, so that's, I can just put a 2 here. So that's 26. I'm going to represent as 2, 6, and then there's 1, 2, there's 3 26s. So 6, comma 6, comma 6. There's 3 27s, so 7, and 2 29s. So there's my 2s, my 20s. And then for the 30s, I have 131. This is just another way of showing the frequency. I've got 3 32s. I've got 1, 2, 3, 4 34s. I've got 138 and 139. You can see there's probably a good chance of making a mistake in all of this. And then 40, I've got 2 40s, so 0, 141, 142, 144, a 45, a 46, a 47, 3 48s, and a 49. And then in the 50s, I've got a 50, a 52, 54, 2 54s, a 55, 56 times 2, 57 times 2, and 58. Now, if I didn't make any mistakes, that should be right. Nice work. All right. All right, construct an ordered stem and leaf display, splitting the stems from part A. So now we're gonna have, let's see how they want us, I'm not sure how they want us to split them. Usually you do them like in 5s or things like that, but I'm not sure what they want. So we're gonna do our best here, and maybe we'll see if we get it right. Sometimes that's part of the problem with like my lab is, you know, the concept they're looking for, but you don't know exactly how they want you to put it, I guess. And so sometimes, and that's part of the reason I allow people to have multiple tries, because it's more about learning than it is about doing it the right way. But we'll see. The other thing we could do is we could look up here and we could say, view an example. And then we can click through. You can see the first part we did. It does an example. But here, oh, look, it has 2, 2, 3, 3, 4, 4, 4, 5. And this one, but that's because none of theirs in this first data set go above 55. So we instead of like I was doing with 25, we're going to do a 2 there. So we're going to do 2 for 26, and a 3 for 31 through 34, and another 3 for 35 through 40. 4, 4, 5. And hopefully we'll get this right. So for the 5s, we have 0, 2, 4, 4. And here we're going to go 5, 6, 6, 7, 7, and 8. So again, we'll see if we get it right, if that's what they were looking for. But this is just another way to display the frequency, the number of times each of these numbers. So in the 2 and the 6 represents 26. We have 26 3 times, 27 3 times, 29 twice, etc. So let's see if it likes that. Oh, it did. Good. So that is the end of problem 4. So let's move on to the last one, problem 5. All right, so for this one, they want us to create a scatter plot. I can show you how to do that in Excel, or sometimes you can just compare the data too, but I'll show you how to do it in Excel. So we'll open this in Excel. And there it is. We'll enable editing. All right, so it says, suppose an internet retailer would like to investigate a relationship between the amount of time and minutes a purchaser spends on its website and the amount of money he or she spends on the order. So time related to how much money they spend. So they've done this with a sample of 12 customers, and they want to see if we can find a relationship. So here's the information. So if we want to make a scatter plot in Excel, all we do is highlight the data, go to Insert, has all these charts, and this one right here is different types of scatter plots. So if we want it to look like the one on there, we don't want any lines in between them. We're just going to choose this one. Now this can be misleading because this is stretched a little more horizontally than these are. You can see these are quite a bit smaller. So in order to compare them better, you have to kind of make this scatter plot you've created similar in shape and size to these. And then we can compare them. So we can like look at A here and see it has all this data down low when minutes are low, and then this little chunk up here, and that's a pretty linear relationship, and that's not shown here in this scatter plot. So A is not it. B, you can see it looks very similar with these high points here and over here. So B definitely could be it. C, this one does not look the same, right? We see these two dots here and that one above it. And so again, you're just sort of comparing them. So C doesn't fit, but D looks like it might as well. You can see D has this same shape here and here and here and here. So it's going to be between B and D. So now you just have to start comparing data, right? And you see that, like, for example, our maximum point here is 400. And if you look at these a little closer, you might see that one of them looks like it goes above 400. But they both kind of do, right? So this is a little harder because now you have to sort of compare these two against our data set and try to figure out which one is more correct, I guess. So this is 10, 20, so at 10 minutes here, we can see about 400. And you can see on this one, all of these things are to the right of 10 minutes. But on our data set, at 9 minutes, that 400 occurred. So it's probably going to be B. You see how there's a little bit of discretion you have to look at through these? And the more you do, the better you get at it. So I guessed that one right, or I not guessed, I got it right. And then describe the relationship between time spent on the website and order size. So there's an upward trend in order size as time increases. That's hard to say, right? Because some of our highest order sizes were down here in low time. There's no trend evident. That's probably true, actually, right? There's not much of a trend. There's not a downward trend either, like the more time they spend, the less they spend in dollars. Or there's a downward trend in time as orders decreases. So looking at this, I would have to say there is no trend evident. And there we go. And that is guided us problem number 2, or for chapter 2, a little longer than last week's, but hopefully it's valuable to you as you move into the homework. Have a great week, and good luck on the homework.